My name is Brian Gomsky, and I'm your host for Engineering Tomorrow, where we talk with top performers and engineering experts about their strategies to optimize indoor air, process cooling, and more. This week, we have John Stacks on the show. John represents Smardt Chillers, which is an oil-free centrifugal chiller design offering the highest IPLV energy efficiencies and lowest lifetime operating costs in their capacity ranges. Get comfortable, pour yourself a drink, sit back and relax as we jump right in.
Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
John, welcome to the show. Glad you could jump on today. So we're talking with John Stacks with Smardt Chillers. John, tell me a little bit about how you got involved with Smardt and a little bit about your background.
So my background comes from the field-erected cooling tower industry. So being part of the cooling loop, I've been familiar with throughout my career, but focused primarily on the large upper-end field-erected type products. With that being said, had an opportunity to go to work with Smardt, selling the premium efficiency oil-free mag-bearing technology that we use, and learning a little bit new product level with the chiller side of the loop. So for me, it was an exciting opportunity, and I jumped.
So tell me a little bit about, so the people on our show, we've got people in school, we've got seasoned engineers, we've got contractors, we have architects. I mean, it's across the board. So tell me a little bit about, starting with the basics, what is a chiller and what does a chiller do?
Well, let's keep it real simple, right? So chiller makes cold. So where you're needing refrigeration, air conditioning, and such, that's where the chiller comes in and produces that removal of the heat from a space. It needs the entire system, obviously, to pull that off, but it is the keystone to that loop and making it happen. Being with my exposure on the cooling tower side and taking that heat extracted from the building to atmosphere, it's a natural fit for me to work over on the chiller side. So from my experience, working with different numbers, working with different processes in the system, we're still removing basically 10 degrees out of that building and making it cool.
Tell me, we hear this a lot. Tell me the difference between an air-cooled chiller and a water-cooled chiller.
With a water-cooled chiller, you're going to have most traditionally a cooling tower in that system. So the chiller removes the heat directly from the chilled water side of the building loop and then sends that 10 degrees basically into the tower loop, which the tower then takes it to atmosphere. Does that through evaporation. If you're using an air-cooled chiller, you're now removing the cooling tower side, and what's happening there, you're still producing the cold water or the chilled water into the building to remove the 10 degrees, but now you're using a coil system with air bypassing over the coils to create the cooling mechanism to take it to atmosphere. So with water, you're going to have higher efficiencies on that capability, but you're going to use water. With an air-cooled unit, you don't use the water, so you have a savings there, which is very beneficial to customers who don't want to have that type of system or are in areas where they don't want to consume water.
What are some of the, and where I'm leading with this is we're going to get into Smardt specifically, but what are some of the maintenance requirements on chillers?
That's one of the advantages that Smardt brings to the market. With our product, we have no oil in our machine. So much of the maintenance that is generated by a chiller is done so around the oil system that's used to lubricate the compressor's bearings to operate. Since we don't have any bearings in there and our bearings are magnetic, there's no oil required. So therefore, the maintenance that is traditionally needed on a traditional oil-based chiller is no longer needed. There are some small maintenance items that you still do to the chiller to keep it in its tip-top shape and continuing its life as it's designed to be, a 25, 35-year piece of equipment. But with the oil-free machine that we produce, in a round general number, it's basically half of what it costs to maintain an oil-based machine. So to an owner, not only do you have savings that are generated from the operation of the machine being much higher efficient, but you're also having savings that are produced through a lower maintenance program. And at Smardt, we offer that same capability through our service group for customers to have it directly from the factory or through any one of our partners that we have in the marketplace that are completely trained and certified by Smardt to work on our equipment.
So on a traditional, just going back to the maintenance, on a normal, excluding Smardt, on a standard chiller that uses compressors, that needs oil, explain exactly what the compressors do, and correct me if I'm wrong, but I would consider them kind of the workhorse of the chiller, right?
Yeah, it's the heart of the machine. What that compressor is doing is it's returning the refrigerant to a position that creates the cooling inside the vessel, which is where the heat exchanging is going on. So the cycle of the refrigerant needs the compressor, and this is on an oil-based machine or an oil-free technology. It needs the compressor to regenerate that refrigerant to its capabilities to create the cooling, therefore producing the chilled water. So yes, it is the heart of the machine. It is what creates its capabilities to produce the chilled water. And for the Smardt side, that's where we focus on the technology that we bring to market in order to create the higher efficiencies in operation of a chiller versus a oil-based machine.
Was Smardt the first company to come out with this technology, the turbo core system, or kind of explain how that process came about and how the thought to even develop this technology?
The Danfoss technology was originally created by one of our founding fathers of Smardt.
Okay.
That group produced this technology and ultimately sold it off to Danfoss. I'm not sure that Smardt, you could say that we were technically the first, but what we bring to market is pushing that technology to the levels and the capabilities that Smardt differentiates itself to our competitors. Meaning, Smardt is the only chiller manufacturer that can go up to 3,600 tons in refrigerant capacity in one machine. In that same machine, we can turn down to about 10% of its capability. So where you have a building that's needing a lot of capacity during the heat of the day, but when everyone leaves and the building's empty in the evening and at nighttime, but still has some heat rejection required, our unit can lower itself down to that very low demand, hence saving that building owner quite a significant amount of money in the turn down capability of our machines, so that during those lower operational demands, that building owner is still saving quite a bit of money with our equipment and technology.
And what technology is in your chiller that allows you to get up to those tonnage ranges in that turn down?
Well, it's basically built into, as we said earlier, the heart of that machine, that compressor, right? So the primary thing is the knowledge and the capability of our people who design and build our equipment.
Mm-hmm.
So we have, because of our background, we have the knowledge and the know-how to control that unit by putting multiple compressors on it to get us up to that 36 and theoretically even higher tonnage on one machine, while at the same time controlling that same machine down to the very low demand needs of turndown. But the controlling of it and the management of those compressors gives us our differentiator in the marketplace that other suppliers just simply aren't doing.
Kind of pun intended, you've got a smart chiller and other people have a dumb chiller.
I'd like to say that, but I don't want to throw any negatives out there. I mean, what's real great about our industry is that we are clearly creating a stir in the marketplace
Mm-hmm.
with many different brands beginning to follow us and produce their own type of technology that's oil free, magnetic bearing type products. So it's a clear signal that what we're bringing to the market has not only accepted, but is driving towards a large expansion. And I can see that in someday in the future that there's no reason why all chillers are oil-free technology. There's simply no need to put the oil into the machine. It's actually more of a negative in the sense that you're lowering its efficiency. Your payback on an oil-free machine is almost always less than 5 years.
Mm-hmm.
And because the equipment's life is arguably 25, 30, 35 years, that payback to that owner is significant. So there is a premium to that efficiency on the first cost. There's no way around it. The technology demands it.
Mm-hmm.
But the payback to a customer is extremely reasonable. We have them anywhere from 1 year out to, depending on features and benefits that a customer selects to put onto the equipment, it can go up to 5 or 6 years. But most of the time, it's around 2 to 3 years on the payback. And that affords an owner the ability to see those significant energy savings and, again, maintenance savings, and in many times installation savings. Because with our machines, if we build a large single machine, they're installing 1 or 2 chillers. You still have your redundancy built in because of the multiple compressors. So you don't need extra vessels, extra floor space. It's built into the machine itself. So again, with what we're offering to the market, it affords itself a very fast return on that investment to the end user.
Mm-hmm. It's an incredibly energy efficient chiller. I've seen these in operation in person, and a couple of the main things I noticed, they're obviously you talk about HVAC equipment, it's a very beautiful looking.
Yeah.
Equipment.
Yeah, it's a very beautiful piece of equipment. It's designed very well and it looks very sleek. And it also, you made the comment, you've seen these in operation versus you go into a traditional machine central plant, you could almost say I've heard them in operation, right? Because the Smardt Chiller is very quiet in its operation as compared to an oil-based machine.
Well, that was my next point. Is we went in there, we stood next to the chiller, and we were actually filming video with just speaking a couple feet apart, and it was so quiet it was almost unnoticeable. What is causing that reduction in noise versus many other brands of chillers that are obnoxiously loud?
It's the oil-free magnetic bearing technology. So inside that compressor, you don't have bearings touching each other, creating the hum.
Mm-hmm.
It just doesn't exist because that bearing is suspended in a magnetized field that allows it to not only be a lot quieter, but much more efficient in its operational cost. And then also no vibrations, or almost, very, very low vibrations is probably the best way to say it, because the metal's not touching the metal.
Mm-hmm.
That's why you don't need the oil in the machine, because there's the lubrication isn't needed. It's in a magnetized field that allows that type of operation and higher efficiencies in its performance.
And then the other thing I've noticed is I liken it to, like, you get into a Tesla and everything's touchscreen. It's got a big screen on it, and Smardt chillers have a very beautiful, at least the ones I've seen, have a very beautiful large touchscreen, and it's got a image of the chiller on it and all your data. Talk to me a little bit about what is on that screen and what capabilities and access you have through that.
Well, on that screen that you're talking about, that user interface is really what people touch, feel, and sense, right? So we try to put on there all the data that someone who is running that piece of machinery, who's responsible for its operation, will want to see. And at their fingertips, literally, they can drill down into that system and see what's going on with it. So we pride ourselves on our automation and control technology, as well as our equipment. And I would even throw in that we offer what we call our central plant optimization technology products that can save an owner, just simply by putting the system up to maybe 30% of its operational cost. And it's brand agnostic. It doesn't need to be a Smardt chiller, although a Smardt chiller in sync with the central plant optimized system will save even more. But what we call CPEX, our central plant optimized controller, basically advises the building automation system that's running the equipment where the set points need to be in order to achieve whatever demand requirements are being sensed into it and required. And in doing that, it's basically looking at the equipment individually to see where the sweet spot of the towers, the pumps, and the chiller are in order to perform at an optimal level. We've got examples of where we've literally turned those systems on after they've been running without it for months. And you theoretically flip the switch, if you would, and we see it on the chart to where it just drops immediately. Mm-hmm. And again, it's just from the system understanding what equipment you have in your central plant and where each one of those items want to be working at most efficiently, and then putting them into a systems platform in order to generate, again, a very significant savings to an end user's electric bill.
You're listening to Engineering Tomorrow, always striving to bring you the best in commercial construction, design, and engineering.
Now, having worked with engineers, and you probably get this question a lot around the country too, they always ask, how long has this technology been around? Who's already installed it? Tell me a little bit about how long Smardt has been using Turbo Core and kind of your installation footprint around the world.
So Smardt builds only with the Danfoss Turbo Core compressor. We don't build you an oiled machine. We just don't offer it. We're experts in what we do, and what we do is what we're an expert in. So we're not like many other manufacturers who want to offer every type of component to the market because they can get a sale. We offer what we do best, which is the magnetic bearing, oil-free type compressor chillers. That being said, there's over 8,000 installations worldwide. We have continuously expanding that number, obviously. We've been in business for almost 15 years now. And many of our people were part of the original Turbo Core team. So again, as I had noted earlier, the knowledge of our team members pretty in depth of that piece of equipment and are able to then maximize its capacity and capabilities in our designs of our chillers. And that we believe gives us a leg up on the competition in terms of what it is we can do and what we can offer our customer base.
Okay. Are there any other innovations from Smardt you'd like to touch on? I know we talked specifically about the turbo core chillers. Are there any other innovations you guys are working on that you can speak about or would like to mention?
Well, of course, we've got a lot of R&D projects that are going on, and it's very exciting to be a part of it and to see what's coming down the pipe. A lot of that stuff we don't like to talk about just yet because, sure, well, for obvious reasons, we don't want to let the cat out of the bag, right? So, yes, we have some exciting technology and products that are on the horizon that will expand our marketplace. But yeah, sorry, just not ready to cut that loose. That being said, what I'd want to really focus on is currently today we have obviously our traditional chillers that we have, which are the water cooled and air cooled, and we also have an evaporative cooler type piece of equipment. And then in markets where you're looking for low GWP or global warming type gases for the refrigerants, we have technology that can help in that areas as well. And we can also put in compressors that can do both. So if someone's wanting to migrate to it later, but not today, we can put a compressor on that runs on traditional current gas refrigerants today, and then be able to convert it over down the road. And then I would also retouch on that central plant optimizer. That right there is a significant piece of equipment that an owner typically has a payback of its install within 2 years. The nice thing about the way we go to market with that versus what a lot of our competitors do is that we sell the equipment to the owner. So we don't have a subscription plan. We don't desire to take a piece of the pie. We want to sell what our product can do on its own merits and then allow that end user to reap the rewards of that investment all to themselves. Those dollars that they save, they're the customer's money. And that's really the product that we bring to market, is the capability for our equipment to save our customers their money.
Mm-hmm. Tell me about maintenance requirements on a Smardt chiller. What does that look like?
As we noted earlier, the maintenance of an oil-based machine, a lot of that maintenance wraps around the oil side capacity of that unit. Because we have no oil in our systems, none required, that maintenance side goes away. So we have inspections, we have general reviews of equipment,
okay,
but nothing of any significance that requires the expenditures that you have on a traditional oil-based machine. At a point out in the distant future, our technology has capacitors, just like all magnetic bearings have, and those capacitors would need to be replaced. And that's currently, we measure that at about a 10-year mark.
Okay.
However, not to go against the O&M manual, but right now we do have some machines that are operating where they're older than the 10 machines and they are 10 years and they haven't replaced those capacitors. So,
it would just be smart when you get close, just make sure you have an extra set. So
exactly. The idea there is that there is maintenance with all machines. You've got to take care of it. It's a machine.
Yep, for sure.
But the focal point that I'd want to leave with is our maintenance requirements are approximately half on an annual basis of what others are. And that creates an ongoing savings to the end user that's not only seen in the energy consumption, but also in its maintenance budget by owning a Smardt chiller.
Okay. Now for an engineer or an end user, what does the process look like if I'm going to do a replacement or even new construction? How do you lay out the cost savings, and do you also factor in maintenance savings when you kind of present that, or how does that work?
Absolutely. Well, we have a tool that we call a TCOM, and it's a total cost of ownership model.
Okay.
And what that tool does, it's a fancy spreadsheet. We had a third party develop it for us, so that it was very neutral in its position. We use it in our sales efforts to really guide us through that selection process to ensure that we're picking the right piece of equipment for our customer. I would argue that any person in the market should be able to use our tool, and we'd be glad to help them walk through it. But you can put in other equipment and look at it as a comparison to our equipment over its life cycle of its 25-year life or so.
Mhm.
And that includes from a maintenance side, it includes from first cost side, and then energy savings side. And then another point is oil degradation. Our tool actually encompasses that as well. And what I mean by that is when you have an oil-based machine, studies have been done that show the oil perpetrates into the heat exchanger and ultimately coats the coils, the tubes that are inside the vessel. And what that does is that reduces its efficiency um, over its time. In some cases, it can go as high as 20-25%
Oh, wow.
of lost capacity because the oil has coated the heat exchanging tubes inside the vessel. Because we don't have that oil, we don't have that degradation to the thermal efficiencies of our equipment. Well, this tool takes that into account and again produces the financial picture of what our machine looks like through an ownership level compared to another example of what you would have in place, be it your current piece of machinery, a new piece of machinery, or whatever. And it looks at it not only from just a maintenance, an install, and a first cost type and the oil degradation, but we're also looking at it from a financial side. So if you're talking to a CFO, we're talking about their return on investments and their financial positions of their own money and
Hmm.
creating an environment for them to be able to look at it from a holistic level to say this is a good investment. And then we actually even calculate the net present value return on investment position. In other words, we put it on the document that says, hey, this is a 2.2 year payback. So to a customer, then, they have to decide what's that comfort level for them for that payback. And if it's within 5 years for a large piece of equipment like this, then you can just simply look at the document and see if it produces its return in that environment. And if it does so, it should be a yes to the purchase for this type of piece of equipment so that they can reap the rewards of those savings throughout the life of the equipment.
Another thing that I'm seeing in many markets, which is also energy companies love products like smart chillers, um, because it is a lot cheaper for energy companies to give incentives for that than building more coal plants or trying to
Correct.
produce more electricity. So I would say another thing to even reduce the cost is look at your local energy incentives, because at least right now and in the markets I'm seeing, there's massive incentives to move to something like a smart chiller.
Correct. It's local market driven.
Hmm.
So everyone needs to look to their local energy suppliers to see what type of products they offer. And by all means, Smart would be glad to help out with anything we can do to help um, get clarity to that and acknowledge what's out there and what we can do to help achieve those rebates or grants.
Yep. And then as we're recording this podcast, there's some pretty enticing federal tax incentives for upgrades as well.
Sure.
Obviously, check with your accountants and at your local level with all that. But
Right.
it's really a great time to be looking at replacing your chiller, and especially in new construction as well.
Well, and I would even throw out a thought that, we're living in a very interesting time in 2020, right? And I think
Not an understatement.
all of us are counting the days for this dilemma to be past us, right?
Yes.
So, one of the things that I encourage a lot of people who I speak to, that this is the time. Now is the time to make those upgrades, because it's always very difficult when you have a building to do a change out of heavy equipment like this, because you've got a demand inside that building that's
Mhm.
traditionally, and for all of our lives in the past, has been a requirement every day. Well, we kind of have an opportunity now with the building load being very low at the moment, that people can make those investments now that will improve that energy efficiency and overall cost of operation of that building. Now's the time to be doing that. From things as simple as accessing the street. If you've got to put a
Yeah.
crane out there to get the equipment on the roof, now's the time to block that street off. Cities are a lot more willing to work with you now because
Mhm.
the traffic flows are lower, and they're going to return. We all know it. The only question mark we have is the when, right? But we all know it's going to return, because that's how we do it, right? So we're going to return to those levels. So while the opportunity is knocking to make upgrades, again, this is where that opportunity of timing comes into play. And it's not just our product. Clearly, it's any type uh, of an upgrade like this that gives a customer an opportunity to improve on their operational cost. I would strongly urge people to be considering doing those type of improvements today.
For sure. John, what is the best way to move forward with getting a um, cost savings analysis and using and getting a report from your software if someone's considering a new construction or a replacement?
Great question, Brian. The first step would be is to contact your local smart representative. Okay, that would be start point one. And then what type of loads you're seeing, what type of design conditions you're wanting, and then let us go through a selection process of our equipment to see what type of equipment's needed, and then also let us know if we're doing a replacement, what equipment you have. It would be real interesting to see what type of load profile that you've been seeing in your building over the last so many years, and then do a comparison between the two. One of the things I'd want to comment is you'd want to do a 10-point type comparison. The reason for this is because with a oil-free machine, the higher efficiencies of that piece of equipment run in the 20 to 60% capacity of that chiller. And what's real interesting is that in most building profiles, we all design these buildings for that 1% day, according to ASHRAE.
Mm-hmm.
Well, guess what? You traditionally never see it, right? So that machine is living its life between a 20 and 60% capacity. That's where that machine's going to live. So that's in our wheelhouse. That's where our sweet spot is on efficiencies as well. So if we get that data in from the current piece of equipment that's in place or that they're considering, then we would compare that to our 10-point data, equal to equal, apples to apples, and then let that software then generate out what that life cycle cost looks like to an end user. And all of our local representatives, no matter where they're located at, Midwest Machinery, obviously, in the St. Louis, Kansas City markets, then contact them, and they can help get that ran for you. And if there's any needs from the factory to help support, absolutely, we're always there to help do what we can do to produce those documents.
And then also kind of for elsewhere throughout the world, what is your website, and what's a way to access you directly?
Sure. So we're online, so you can just get on your favorite search engine, type in the word smart with a D, and let it pull up. And it'll be both our website, it will be your local representative's website, and
Go from there.
I think it goes from there. But for the Smardt website, it's www.smardt.com, and all of our contact capabilities there are listed there. But again, I would challenge to go there for the information, but contact your local representative, because that's where the magic's going to happen, is working together to develop what it is that your needs are based on that local weather climate is really the best approach.
Okay, great. John, I want to thank you for being on the show, and Smardt as well. Again, thanks again, and to all our listeners, have a great day.
Brian, thank you for having us, and to you and all, have a wonderful, wonderful rest of the week.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.